Determine whether the relation defines a function. What we want to recall here is the definition of a function that each input corresponds to exactly one output. If we first focus on part B and the input C, we can trace that to the outputs 25 and 49. So let's take that out of the relation diagram and write it off to the side. This is a good example of an input corresponding to more than one output, so we would say that this is not a function. If we now look at example A, we can see that here each input corresponds to exactly one output because we have only one arrow coming out of each output. It's true that there are two arrows going in to the number 25, but two arrows going to one output is not a problem. An output can have more than one input, but each input must have only one output. So example A, the relation does represent a function, and in example B, the relation does not. Going on to the equations, the first thing that we notice in these is the plus or minus symbol in example C. This has the effect of creating two outputs for one input. If we take, for example, x equals 9 as our input, then the positive square root of 9 is going to give us 3, and the negative square root of 9 is going to give us negative 3. This is two outputs for the input 9, and therefore we would also say that this is not a function. Whereas in the following example, we just look at where the variable appears and imagine the process of evaluating this expression. I would take an input for x, I would multiply that number by 1/3, then I would subtract 7. It's impossible for me to get two different numbers just by performing these operations. So the absence of the plus or minus symbol here, combined with the fact that it's already solved for y, tells me that yes, this is in fact a function. As a general rule, a plus or minus symbol is how we recognize that an equation does not represent a function. And if the plus or minus symbol doesn't show up in the original form of the equation, it would show up somewhere along the way in the process of solving for y. So if it's not possible to solve the equation for y without introducing a plus or minus symbol, then your equation generally does not represent a function. If it is possible to solve for y without introducing this plus or minus symbol, then it generally means that the equation does represent a function. Okay, going on to our two graphs, we want to remember the vertical line test. It's just an easier way than thinking about the definition of the function and first principles every single time. The vertical line test, if we start down here with example F, the vertical line test says that if it's possible for me to draw a vertical line that intersects my graph more than once, then the graph is not a function. If, on the other hand, it is not possible for me to draw such a line, or if every possible place that I could draw a vertical line intersects the graph only once, then that tells me that the graph does represent a function. So this here, this E, would be yes for this reason.